Okay, so here we are, and we are going to talk about today congruence transformations, and we'll talk about what both of those things mean here in just a second. So let's start with the word transformation. A transformation in geometry or in algebra is when you take a shape and you move it. You change it somehow. So the different ways we can move it are called a translation, a reflection, a rotation, and then the last one, a dilation. Alright, so you've heard of some of these before. You've heard probably of the translation referred to as a slide in previous math classes. The reflection is a flip, and the rotation is a turn. So if you've heard of those terms before, we are now just talking about them with more complicated terminology. The official terms for that are translation, reflection, and rotation. And then we'll talk about dilation as well in just a second. So here we go. We've got the original image, the original figure is called the pre-image. Pre meaning that's where it came from. That was the first thing. So here we have the pre-image, image next, or figure next. And sometimes the pre-image is also referred to as the parent. Then we have the image, which is this guy. That's the moved figure. And the image is also sometimes called the child. This makes sense, of course, because we know children come from parents. So in the similar way, the image comes from the pre-image, it's just moved. So the image is the moved figure. And notice some differences here. You have the pre-images, the vertices are named with capital letters, N-E-X-T, whereas the image is named with vertices and with capital letters and a prime. This apostrophe on all of these is called a prime. And that just denotes that x prime is corresponding to x in the pre-image. Those are the same point. X prime is just x, and it's now been moved. Alright, so let's talk more specifically about congruence transformations. So congruence transformation, and this is called different things. Sometimes you'll hear it referred to as an isometry or a rigid transformation. These are transformations that move the figure. It moves the figure, but it does not change its size or shape. Okay, so the ones that do not change the size or shape are the translation, the reflection, and the rotation. The ones that do change the size or shape, specifically the size, not really the shape, is the dilation. Changes the size. And we'll talk about that in a later chapter. That one's called a similarity transformation instead of a congruence transformation. But it makes sense that these are called congruence transformation because both the original figure, the pre-image, and the new figure, the image, they're congruent. They're the exact same size, exact same shape. So here we have identify each transformation in example 1 and verify that it is a congruence transformation. So two things we have to do, identify and verify. Okay, so we recall that this would be a mirror image. What we have on the left-hand side is a mirror image of what we have on the right-hand side, and the word for that is a reflection. So this is a reflection, also known as a flip, because it looks like somebody just took it and flipped it across the y-axis. But reflection's the actual word we're going to use for that now that we're in geometry class. If it was a rotation, it would have looked rotated, it would have looked turned. And if it was a translation, it would have been facing the same way. It would have just been moved up, down, left, or right. So this is a reflection, since it looks like it was just flipped across the y-axis. And then to confirm that this is indeed a congruence transformation, we're going to confirm that all the sides are congruent, all the sides are the same length. So we have side AC, side CB, side AB on the first triangle, and we're going to confirm that those three sides are congruent to DE. You'll have to excuse my dog in the background. DE, EF, and DF. Alright, so here we go. We have AC, all I have to do is count the squares. 1, 2, 3, 4. And DF is 1, 2, 3, 4 as well. We have one pair of matching sides. I could have written that probably in a different order. And then we have, okay, so to find the length from A to B, we're going to go over here in our side work and do the Pythagorean theorem. We're going to do A squared plus B squared equals C squared. So that's 1, 2 squared plus 1, 2 squared. So 2 squared plus 2 squared equals AB squared. So that's what? 4 plus 4. So that's 8. And then we'll square root both of these. So AB equals square root 8. Then we come over here to DE, and conveniently our right triangle, when we go to do our Pythagorean theorem, is also 2 by 2. So of course we know it's going to also come out to square root 8, since we're going to basically have the same equation here. So DE is square root 8. Then we go to find from B to C. Oh, wouldn't you know it, it's 2 by 2 as well. So it's also going to be square root 8. And EF conveniently is 2 by 2 as well, so it's also square root 8. So let's check. Do all my sides match up? I have 4 and 4. I have 8, square root 8 and square root 8, and another square root 8 and another square root 8. So the triangle ABC is congruent to triangle DEF by side, side, side. All right, so let's look at our first transformation here. Let's look at the translation. The notation for that is the T stands for translation. Then the first number in those angle brackets tell us that we are going to move left or right. If it's negative, you'll move left. If it's positive, you move right. And then the second number is going to tell us if you're moving up or down. Then what's in the parentheses will tell you what you're moving. So in the first situation, we have that we are moving triangle ART. In the second one, we are moving the coordinates X and Y. So here we go. In example 2, graph the image under each figure under the given translation. Use prime notation to label the vertices of the image. So I have trapezoid math, and you can see that's the shape we're moving right here. And we're going to translate, that's what the T stands for, 3 to the right. I knew it was to the right because it was positive, and 4 down because 4 is negative. So I can pick any old point I want. It doesn't matter which point I choose. I'm going to choose H because I feel like it. And I'm going to move 1, 2, 3 to the right and 1, 2, 3, 4 down. And this is my new H. This is my H prime. Then we're going to do the same exact thing for all the other points. So T, you're going to move T. 1, 2, 3 to the right, 1, 2, 3, 4 down. This is going to be T prime. Do the same thing for A. So if you wanted to, you can also see that there is just a space of 1 here. So if I go 2, 3, 4, I lost my P prime. If I just go over 1, the corresponding point for A prime will be there as well. And then from H to M, it looks like there was a space of 3 blocks. So if I go over 3 blocks, 1, 2, 3, my matching M prime will be right there. So you really could just do 1 point and then do all the others based off of that. I'm going to give you a second to pause the video and try the U try here, and then you can come back and check your answer. Okay, so I know I'm going 2 to the right and 3 down. I've already mapped X prime and Z prime. Y prime would also be 2 to the right and 3, 1, 2, 3 down. For Y prime, connect the dots. And there you go. There is my image. So I'm going to conclude this video, and then you can, when you are ready, look at the other examples, but that's enough to at least get you started with your worksheet.